Here we are given a 3D object. It's a half circle cylinder whose length is 3 and the radius of the half circle is 5. And the question is to write a triple integral that would integrate this function g over this 3D object. Now, when you try to do rectangular integration, you could do dz, dy, dx, which is the one that I usually like to do, because if you integrate by dz first, then this is just regular double integral x and then y. But here I think integrating in the x direction is better than whatever. This could be like dy dz or dz dy. We'll think about that later, but I want to integrate by dx first, because see, if you integrate in the x direction starting from this end until this end, once you've integrated it, then the object gets flattened like a pancake on the zy axis, and on the zy axis you have a very simple picture, which is just a half circle. And now that's very easy to handle. So I choose dx first. But this is not the only way. There could be other approaches. You could certainly do dz first. It's up to you. Okay. So I want to rewrite this as integral with g, x, y, z dx first. So I have to think about what x is equal to and what x is equal to. And remember, this is surface to surface, curve to curve, point to point. So here I have to provide from which surface you start to integrating and where you end, right? And in this picture you see that you start on this side, this side, on the opposite end from our view, and you end on this side, which is towards us, the surface towards us. And although this surface here looks like a half disk, and you might wonder what's the equation for that, it's actually part of this YZ plane. This is the YZ plane, and YZ plane is described by x equal to 0. Okay, so in other words, every point on here, on this side, will have x equal to 0, x coordinate as 0. So x equal to 0 is where this dx begins, and then you stop on this side, which is part of this surface, and because you've moved 3, this equation will be x equals to 3. So you start from 0 and then you end at 3. And after that, like I said, that after you integrate, then you end up with this half circle, and you have to now think about how to paint this this area. And you have two choices. You can paint this rightwards or going upwards, but I choose the upwards one because that's easy, because this side here is just z equal to 0, so that's very easy to think, and therefore all I need to do is to figure out what this curve is. Now this is a radius 5 circle. It's part of the radius 5 circle, so this curve, any point on this curve would satisfy the following: y squared plus z squared equals to 5 squared. And as you know, this is like x squared plus x squared plus y squared equals to 5 squared is the radius 5 circle. But because we are on the YZ plane, we have to use y and z instead of x and y. And because I want to go up, that means I have to choose dz here. And then that means over here I have to put z equals to something and z equals to something, and as a curve to curve, and it's the bottom curve is this one and the top curve is this one. So you go from this curve to that curve. I already said that z equal to 0 is the top curve, so 0 will be over here. But to get an equation out of this, as z equal to something, you have to solve this for z. So how do we do that? We solve this for z as z squared equals to 5 squared is 25, 25 minus y squared, and z is therefore plus or minus square root of 25 minus y squared. However, we choose the minus one because the circle is below the y-axis, right? So z is negative here. So we choose this equation here as z equals to negative square root of 25 minus y squared. And once you've integrated that, then this again flattens, and then it just becomes this interval, right? And because this is a radius 5 interval, the interval begins from negative 5 until positive 5. So it's from negative 5 until positive 5. Since it's messy, let me rewrite the answer. So answer would be, you go from negative 5 to 5. And you go from negative square root of 25 minus y squared until 0. And then you go from 0 to 3 of g, x, y, z, dx, dz, dy. Okay, forgot the dy here. Okay, so that's the final answer.